joined? Can you message me? Who all are joined? Type your name so that I'll come to know that who all are joined. So today we are discussing about the second chapter in the physics, that is motion in a straight line. So we are starting the chapter motion in a straight line, class 11 CBSC. I hope everyone is joining. Who all are joining? Who all are joined? Message there. Keep a message. Okay. So as this is a motion in a straight line, motion in a straight line. Okay. So this is the second chapter in physics 11th CBSC. So motion in a straight line. Motion means what the object is moving. So how this motion and all derived? So there is a basic concept is there, that is a mechanics. Okay. So mechanics is nothing but a branch of physics and which involves the study of the movement of different objects. And this mechanics or the movements are categorized into different parts. One is static, another is dynamic, and another is nothing but kinematics. If possible, you can note it down. Okay, so notes I will provide you later. So mechanics is nothing but what? It is a branch of physics and which involves the study of different movements of the objects. So these movements are categorized as a static, dynamic and kinematics. Okay, static means what? When the object is at rest. Static means object is at rest. Dynamics means object is in a motion. And what do you mean by kinematic? Kinematics we learned. Okay, do you know the kinematics? Kinematics is also a branch of what? The physics, and this is also study of a different object movement, or this is there is kinematics is also a study of a movements of a different objects, but we are not considering the cause of movement, that is nothing but kinematics. And we learn three different equations. Okay, and there is a initial velocity, final velocity, acceleration, time, distance covered. Okay, we are not considering how that object is started in motion or in a rest, that we are not considering, but that is also one kind of study for the objects which are in motion. Even dynamics is also what? The branch of physics, and we are discussing or we are studying on the objects which are actually in a motion. And in static, this is also branch of physics which involves the objects which are actually in a rest. So that is nothing but what? Statics. So this is nothing but the mechanics, and this mechanics contains the three different parts, that is a kinematics, dynamics and statics. Okay, so right after this here we have one more part. Okay, we know this, but still I am explaining this because it is given at the beginning of this chapter. So first is nothing but what? Rest. Rest is nothing but what? The object is in the rest condition. Okay, means suppose if I am considering this as a room. Okay, and in this room this board is there. So this board is at rest condition with respect to that class, or with respect to this room, that board is what? the rest board is at a rest condition, means there is a no movement of the board if we consider this room. Okay, so here we can say that the object is to be in a rest. Okay, object is to be in a rest means that object is not moving here or there, or the object is not in a motion for that particular given area. Okay, that is nothing but rest. And what do you mean by motion, or what do you mean by or what do you mean by motion? Motion is nothing but what the object is said to be in a motion when it changes its position again and again, or it is continuously changing its position with respect to surrounding. Okay, is nothing but what motion. So for example, we can walk in one room to another room, people are running, vehicles are moving from one place to another place. These all are the example of what? Motion. Rest means object is not moving, the position of the object will remain same, and in motion the position of the object is continuously changing. And in rest, I gave the example, if we take this as a room or classroom, there is a board, this board is at static condition, that is it is at a rest condition. And motion, that means what? I am moving here and there in this room, means according to the surrounding I am only in a motion because I am changing my position. Okay, so rest, position is fixed, position is fixed. And here what? Position is changing. Position is what? Continuously changing. That is nothing but what? Object in a motion. Can you all getting up to here? Who all are there? Okay, everyone can take a screenshot up to here. Okay, copied everyone. Okay, everyone, I request everyone to take the screenshot of this. Now we have to discuss about the position, distance and displacement. Okay, position, distance and displacement. So everyone copied this much, everyone took the screenshot. Okay, so these are the just key points I am writing, and afterwards I will provide you the notes. Okay, understanding of concept is very important. Now we are discussing about the position, distance and displacement. Position. Okay, so we can discuss first position. So in this chapter or in a motion, a plane, any chapter you can take in the physics. Okay, or not only in physics. Suppose I want to move. Okay, suppose here there are two cities. One is Delhi and another is Mumbai. And I want to fly from Delhi to Mumbai. Okay, so I am giving a reference. No, I want to fly from Delhi to Mumbai. So Delhi is what? My reference point. Delhi is my reference point, and Mumbai is my destination. Okay, but from where to where I am going? I am going from Delhi to Mumbai. So Delhi is a reference point. So similarly in physics also, whenever we are saying object is moving from one place to another place, what is that one place? Okay, what is that place? That place is nothing but we are taking it as a reference point. Okay, suppose here I have the point A and here I have a point B. Object want to move from A to B, so I am telling here, I am saying here object is moving from A, means it is leaving the position A. So position A is nothing but what? Here reference point. Okay, that means we are taking it as a origin here. We are taking this as a origin. So why I am taking origin? Why we require reference point? If I don't have a reference point, then can you calculate the distances? How that object is moving from A to B? What is the distance? We don't know. So what is the origin? From where it is started? Okay. Suppose if you are telling your friend, oh today I went to Mumbai. From where? If you are only saying I am going to Mumbai, from where you are going to Mumbai? how much is the distance. Okay, so to give all these details we require origin, or that origin is also known as what? The reference point. Okay, so position is nothing but what? The object which is kept at one particular place, and that point we are taking it as a reference point, and that reference point is also known as what? Origin over here. Can you getting? So to express the change in position we consider two physical quantities. Okay, to express the change. Okay, to express the change from A to B we require two quantities. One is a reference point and another is a destination. That is nothing but position. Can you getting this position? What do you mean by position? Okay, so position of any object is expressed with the help of reference point. That reference point we require origin, and this position is useful to give the difference between the two objects. Okay, and that require the two physical quantities. Copy this, then we can go for the next point, that is a distance. Who all are there? Can you message your names so that I will come to know that who all are joined? Okay, everyone copied here. Who is there? Okay, Ryan joined. Okay. Tomorrow I'm joining. I will inform. Okay, so this is the position. Then next is different distance. Okay, next point is nothing but what? Distance. So what do you mean by distance? So here object A means some object move from point A to point B. Okay, so it covers some path length, or it covers some path, and that path is measured in terms of length, and that is known as a path length, and that path length is nothing but what? The position. Can you getting this? Not position, distance. It refers the actual path covered by the object during the course of motion. Okay, so actual path length. Hello. ही जस्ट क्लास चालू आहे हां okay. Now here it take actual path length means object A means object moving from A to B. So for moving, how much distance it moved, okay, how much path it covered to move from A to B, that is nothing but what? Path length. Okay, and that path length is nothing but distance, and distance is measured in terms of meter. Its standard unit is what? Meter, and dimensions are nothing but what? L raised to 1. Okay, because n 0 and t is also 0, and distance is nothing but what here? The uh, only L1, and distance is nothing but what? Your scalar quantity. This is a scalar quantity, very important. Copy this. Then we'll go for the next point, that is the displacement. Okay, I hope everyone took the screenshot of this. So now we can go for the point displacement. So displacement is nothing but what? Object is started from A and finish its journey at B. Okay, the difference between the path length. Okay, means difference between initial path length or initial point to final point. Okay, that length, the difference between initial point to the final point. Okay, that difference is there. That difference is nothing but what? Displacement. Okay, during the course of motion or during the motion from A to B. That is nothing but displacement. Displacement is also measured in terms of meter and its dimension is also L1, but this is not a scalar quantity. This is nothing but a vector quantity. Okay, why a vector quantity? Because we are giving not only the magnitude but we are giving here the direction also, from where to where I am moving. But distance is a scalar because I know only distance. I am telling only 2 kilometer distance I covered, but in which direction I am not telling. That's what distance is a scalar quantity and displacement is a vector quantity. Okay, so vector quantity where we are informing both magnitude and direction, and scalar quantity only we are giving a magnitude over here, and both displacement and distance are measured and the dimensions are nothing but what? L1. Okay, getting this, take a screenshot. Now next point is nothing but difference between the distance and displacement. Okay. Okay, finished. Now next point is nothing but distance and displacement. Okay, we are considering here the difference between the distance and displacement. Very important difference, mostly in exams they are asking. So normally just now I gave the displacement and distance differences. Okay, means indirectly I gave here. So I will make here two columns. This is the distance and this is nothing but what? Displacement. Just now we discussed what do you mean by distance. Distance is the actual path length covered during the motion, and displacement is nothing but what? Difference between initial point and final point during the motion. This is what I wrote, the difference. That is nothing but your difference first point. Okay. Second point, distance is nothing but what? A scalar quantity. It is a scalar quantity, and this is nothing but what? A vector quantity. This is nothing but your vector quantity. Okay, so these are the two main differences I got. So you can again add some points. Always remember the distance covered by the object is always positive. The distance covered distance is always positive. Very important. It never be negative or never be zero. Distance is always positive. Then what about the displacement? Displacement is nothing but what? The magnitude of a displacement is always less than or equal to the distance traveled. देखो displacement is always less than or equal to the distance. Okay, so maybe this displacement may be negative. Okay, so maybe zero. I am not saying it's negative, it's a zero. Okay, and but distance is never negative or never zero, it is always positive. Okay, so distance is depend upon the path traveled by the object covered how much distance. Okay, depends on that we can say that the distance is dependent upon the path traveled by the object. Distance is depends on the path object covered. And what about the displacement? The magnitude of the displacement is not depend. It is independent of the path taken by the object during the course of motion. Okay, so displacement is a independent. It is independent of the path covered by the object. Okay, so these are the 4 points are there for distance and displacement. So what are the distances here? So distance is nothing but actual path length covered by the object during the course of motion, and displacement is nothing but difference between the initial position and final position during the course of motion. Very important, distance is a scalar quantity, displacement is a vector quantity. Then here distance is always positive but never be negative and zero. Very important point. Displacement whose magnitude, means I am saying here its value is less than or equal to the distance. Okay, that means distance is always greater than the displacement. Getting this? And last one, distance is a dependent on the object, how much path it covered. Okay, it depends on the path length covered by the object, the distances. But displacement is independent of the object, how much difference, or it is independent of the magnitude of the path length, is nothing but what? Displacement. Okay, so these are the 4 points we have. So prepare this, take a screenshot or you can note it down. Okay, finished. Everyone took the screenshot. So now next point, difference between the speed and velocity. These all are the differences. Mostly they will ask in the exam. That's what I am explaining. Anyhow, you know the concept of displacement and distance. And here it is very important. Mostly they will ask the MCQ question based on this point. Okay. If you check your worksheets, previous worksheet, question papers and all, they will ask distance is positive. Yes. Distance is negative? No. Okay, distance is negative? No. They will give the option. Displacement is what? Always less than or equal to the distance. Okay, or we can say that distance is always greater than the displacement value. Very important points these are. Okay, so now we are going for the next difference, that is speed and velocity. Okay, speed also we know that and velocity also we know that. In class 9 we learned speed is a scalar quantity and velocity is a vector quantity. Okay, so speed is nothing but what? Total distance covered upon total time required, and velocity we know that to change in the or we can say that displacement upon time. Okay, and the distance is measured in terms of meter and velocity is measured in terms of meter per second. But velocity is a vector quantity because we are giving a magnitude as well as we are giving a direction. But speed is only a scalar quantity. We are providing only magnitude, not the direction. Okay, so these are the points. Already you know that. Okay, but we have to arrange in a proper way. So here we can write here speed and this is velocity. Okay, speed is nothing but what? Total distance covered upon total time, and velocity is nothing but what? velocity is nothing but displacement divided by what? Time. Okay. Second point, this is what? First point. Second point, this is a scalar quantity. It is a scalar quantity. This is a vector quantity. Then next, so speed is never be. Speed always positive during the course of motion. Speed is always positive during the motion of the object. And velocity is maybe what? Velocity may be positive, may be zero, or may be negative. Velocity, or I will write V, may be positive, may be negative, or zero. Getting this? Because whenever there is a traffic, then we are changing. Speed will become what? Changed. Okay, it is going decreasing. So maybe it's zero, maybe positive, or maybe negative, but speed is always positive during the motion. Okay, and one more important point, that is nothing but the speed is greater or equal to the magnitude of velocity. The speed is equal or greater than the magnitude of velocity. And what about the velocity? Velocity is always less than or equal to the speed. Okay, so write down here, velocity is less than or equal to the speed. Okay, just reverse it, you will get the answer. Okay, so speed and velocity, these are the difference point. So speed is nothing but total distance covered by total time. Velocity, displacement by time. Speed is a scalar quantity, velocity is a vector quantity, because we are giving here magnitude and direction, and here we are providing only direction, only magnitude, not direction. So speed may be always positive during the course of motion, but velocity is what? May be positive, may be negative, and zero. So whenever we apply the brakes, so speed is what? Get reduced. Okay, that is nothing but what? Negative velocity. If we increase the speed, that means that is a positive velocity. If the object, once you apply the brake, then car will stop. In that case, velocity becomes zero. Okay, and that due to change in velocity, there is an acceleration generated. So speed is always greater than or equal to velocity, and velocity is always less than or equal to the speed. So these are the 4 points are there for the speed and velocity differences. Okay, so very important, last point is very important, note it down, make a bracket or you can box and take a screenshot of this. I hope you all are getting. If you have any doubt, kindly message in the chat box. Jareen, are you there? Only Ryan is there. Ishan, are you there? Ishan, are you there? हो गया चलो नेक्स्ट इज स्केलर and vector quantities. Okay, scalar and vector quantities. So already we discussed many times, and now still I will teach you. Scalar only we are giving magnitude. Scalar only gives a magnitude, and what are the quantities, physical quantities comes under the scalar quantity. In scalar quantity, there is a mass, we are only saying the values, not the direction. Mass is there, then time is there, okay, speed is there, okay, then work, length, then temperature, okay, these are nothing but the scalar quantities. And what are the known, what do you mean by vector quantities? Vector quantities, these are giving, means both magnitude, and direction, both magnitude and direction is given by the quantity, is given by the quantity, okay, both magnitude and direction is given by the physical quantity. So here vector quantities just now we discussed, that is velocity, for example velocity, then displacement, and any other quantities, do you know, they are comes under the vector quantity. So we have a force, torque, momentum, okay, force, torque, momentum, even acceleration and comes under what? Vector quantities, okay, scalar and vector. So these are the scalar and vector quantities. In scalar only there is a magnitude is given, and for example mass, time, speed, work and length, temperatures are comes under the scalar quantities. In vector both magnitude and directions are given, means I can say that I am traveling from Mumbai to Pune, and Mumbai to Pune distance ultimately we are calculating. So that's what vector quantities are giving, both magnitude and direction, or represented by both magnitude and directions, okay. And for example here velocity, displacement, force and torque, momentum, acceleration, these are the examples of the vector quantities, okay. Understood? Everyone can copy up to here. Everyone took a screenshot? Okay, now next is average velocity and average speed, okay. That is nothing but the next part. We have average velocity and average speed, okay. So I can teach this in the form of difference, that would be a better to understand, because mostly they will ask the differences, or maybe they will ask the dimensions, okay. So that is the reason we have to do the comparative study of these quantities, otherwise this chapter contains lots of definitions, okay. So here first is a average velocity, and here average speed. This is nothing but average speed. So average velocity, is nothing but what? I will write here V average. I will represent average velocity as a V average, and this V average or average velocity refers to the change of position or displacement. Okay, change in displacement, because velocity is nothing but what? Displacement. So here average velocity is nothing but what? Change in position or change in displacement divided by what? The time interval, or we can say that divided by time. So why here change in displacement? Because velocity is what? Continuously changing, or if the object is changing its position again and again. So that's what here V average we are taking it as a change in displacement divided by time. That means it covers some unequal distances in each case, okay, or during the course of motion. Means suppose in 1 hour it covers 2 kilometers of a distance, then next 1 hour maybe it covers 5 kilometers of the distance. So speed here, velocity is what? Continuously changing. That means the displacement by the object is also different. So that's what V average is nothing but change in displacement upon time. So here average velocity is also measured in terms of what? The SI unit. Okay, it is SI unit. Average velocity is also displacement. Change in displacement is also meter, and time is measured in terms of second. So here the dimensions are nothing but what? m0, l1, t raised to minus 1. These are the dimensions for average velocity. Can you getting this? And sometimes if the values, the displacement is in larger quantities, then we are writing kilometer per hour, okay, or kmph. Then what about the average speed? So here average speed is nothing but what? Total path length travel. Okay, so I can write here average speed, average is equal to what? Total path length, total path length divided by what? Time is nothing but what? Your average speed. So total path length divided by time is nothing but what? This is also measured in terms of what? Meter per second. So its SI unit is nothing but what? Meter per second, and dimensions are also here m0, l1, t raised to minus 1. So now people are asking, ma'am, what is the difference in between them? Okay, this is average velocity, this is average speed. Okay, speed is a scalar quantity and velocity is a vector quantity. Here this displacement is independent and this speed is what? Dependent on the path which is covered by the object. Okay, but measuring SI units are remain same, dimensions are remain same. Okay, but the concept is like that. This is a independent quantity, this is a dependent quantity, okay, and velocity is a vector quantity and this is a scalar quantity. Here we are only giving the value, we are giving only magnitude, not a direction. But in average speed we are giving direction as well as magnitude. So average velocity is defined as what? The change in displacement over the time, and it is measured in terms of meter per second, and if the values or distance or path length displacement is more, the bigger, then we can measure in terms of kilometer per hour. Then dimensions are m0, l1, t raised to minus 1. Speed is nothing but what? It is defined as a ratio of total path length over a time, and it is also measured in terms of meter per second, or you can say that kmph, that is kilometer per hour. If the speed is more or distance covered by that object is more, then you can write it as kilometer per hour. Dimensions are m0, l1 and t raised to minus 1. I hope it is clear with you. It's very easy, simple definitions. Okay, take a screenshot, then we can go for the instantaneous velocity and instantaneous speed. You can copy or you can write down this. Okay, finished. I hope everyone is getting. Now next is instantaneous velocity. Instantaneous velocity. I can write as a VI. Remember, instantaneous velocity is nothing but the average velocity we are expressing. Okay, instantaneous velocity is nothing but average velocity where the time, okay, time will become infinitely very small when we take the limit of the instantaneous, when we take a limit of the displacement. Okay, so we can write here limit t tends to 0 or t tends to 0, then we can write here delta x. We can write it as a delta x by delta t. Delta x is nothing but what? Change in length. Okay, and delta t is nothing but change in time. So this also we can write it as dx by dt. Okay, dx by dt is nothing but what? X is a distance or displacement and t is a time. So whenever we are taking instantaneous velocity, then time will become what? Infinitely very small. Okay, limit t tends to 0, delta x by delta t. Now for your syllabus, they will not ask anything in detail, but if instantaneous velocity comes, then you have to write this expression along with the definitions. So how the definition of the instantaneous velocity comes here? So it refers to the velocity. It is refers to the velocity at the instant of time t, and this instantaneous velocity is further expressed as a limit of the average velocity during the time interval dt or delta t becomes infinitely very small, and this we can express in terms of vi is equal to dx by dt. And here also instantaneous velocity SI unit is nothing but same, meter per second, and dimensions are L1 t raised to minus 1. So these are the dimensions and the SI unit is meter per second. It will remains same. Getting this? Or we can say that rate of change of position with respect to the not position, rate of change of displacement, okay, with respect to time is nothing but instantaneous velocity. Okay, now what do you mean by instantaneous speed? Exactly ulta. So I will make a note over here, instantaneous speed. Instantaneous speed is nothing but what? How can we write instantaneous speed? Here S I is nothing but, we can write here instantaneous speed is nothing but the speed refers to the magnitude of velocity is nothing but instantaneous speed, that is a path length over a time. That speed is nothing but your instantaneous speed, and here it is also measured in terms of meter per second, and the dimensions are here L1 t raised to minus 1. Okay, so instantaneous speed is nothing but what the length, the total path length it is covered, that is nothing but your instantaneous speed. Okay, so similar definitions are there wherever it is difference that I am telling you. Okay, getting up to here. Okay, you can take a screenshot, and after this we can discuss the acceleration. Okay. Once we finish the acceleration, then we can slowly move towards the kinematics. By the month of July 15th onwards, I am taking only first and second, only the question answers we are doing. Okay, everyone took the screenshot of this. Okay, finished. Chalo, next part, acceleration. Okay, so acceleration is also very important. Okay, those who know the velocity, then it is very easy to understand about the acceleration. Okay, so acceleration is nothing but what? Change in velocity. Okay, I will give it again. Acceleration is nothing but what? Change in velocity. Okay, so when and where the acceleration caused and how acceleration is caused. Suppose I am moving with certain speed. Okay, so in 5 minutes I covered something 1 kilometers of the distance. Then next 5 minutes maybe I covered only 500 meter. Okay, means initially I covered 1 kilometer, after that I covered 500 meters. The next 5 minutes I covered something 700 meters of distance. Again next 5 minutes I covered only 100 meters of the distance. Means in every time interval the distance covered by me is changing. Maybe that is increases or maybe decreases, maybe remaining constant. Remaining constant, that does not create the acceleration, but in a successive time interval I am covering different distances is nothing but what? The acceleration. So that means what? In first 5 hours maybe my speed is more. In next 5 minutes my speed is maybe less. And next 5 minutes I increase the speed, but I can't able to cover 1 kilometer of the distance. And in next maybe speed is less because maybe there is a traffic or many certain other barriers are also there. So in this case I have a barriers, because of that I am covering a different distances, okay, in a successive time interval, and because of that the velocity maybe increases or maybe decreases in a successive intervals of a time is nothing but what? The acceleration. That's what I am saying. If there is a change in velocity, that change in velocity causes the acceleration. Can you getting this? So acceleration, SI unit, acceleration, change in velocity. Okay, acceleration is nothing but what? Change in velocity with respect to time. Okay, so acceleration we can write it as change in velocity divided by what? Time. Okay, change in velocity is a velocity we are measuring in terms of meter per second, and time is also measured in terms of second. So here SI unit is what? Meter per second square. This is nothing but your acceleration. And acceleration SI unit is nothing but what? Here m is 0, L1 t raised to minus 2. This is nothing but what? SI unit of the acceleration. Can you getting this? And if we go for a average acceleration, A average is nothing but what here? A average is nothing but V2 minus V1 divided by T2 minus T1. That is change in velocity with respect to change in time is nothing but what? Average acceleration. Can you getting this? Understood? And what is the instantaneous velocity, instantaneous acceleration? I will write AI. AI is nothing but instantaneous acceleration. That is nothing but dv by dt. That is dv is a change in velocity with respect to dt. That dt is also change in time. So these are the three concepts we have. That is the acceleration, average acceleration, and instantaneous acceleration. So here acceleration is nothing but change in velocity with respect to time. A is equal to change in velocity by time. So I wrote here meter per second, and time is nothing, we are measuring in terms of second. So its unit will become how much? Meter per second square. Meter, that means length, second is nothing but time. So here t square, so whenever the t square comes up, it will become what? -2. Then average is nothing but change in velocity with respect to change in time, and average instantaneous acceleration is nothing but dv by dt. So this is nothing but acceleration. Which acceleration? Normal acceleration, average acceleration, and instantaneous acceleration. I hope you all are getting this. So write down this quickly. Quickly you can note it down. You all are getting? Any difficulties or doubts you have? Does anyone have any kind of doubts, queries? Okay, copy this fast. Then right after this we will go towards the uniform, non-uniform motions. What are the kinematics equations? That also we can do. I will give you the schedule for chapter 1 test. Okay. Even chapter 1 I am taking some questions. Still some questions are pending. That also I will cover. Okay, everyone copied? So in class 9 we learned about the kinematics equations. Okay, so total 3 kinematics equation we learned. Those who copied, it's okay. Those who are not copied, they can take a screenshot. Okay. So in class 9 we learned the 3 kinematics equation. I will just explain the 3 kinematics equation. First we learned v is equal to u plus at. Another is v square minus u square is equal to twice of at. And next is s is equal to ut plus half at square. So these are the 3 kinematics equation we learned, and there we know that v is a final velocity. V is a final velocity, u is a initial velocity, then t is a time, s is a distance covered, or we can take it as a height, and a is nothing but here acceleration. Okay, these 3 equations we learned in the class 9. Okay, so this year now we have to derive the equations. All the 3 equations we have to derive. Then we have to discuss about the graphs. Okay, position, time, distance, time, that all graphs also we have to discuss. So v is a final velocity, u is the initial velocity, a is the acceleration, and time t. So v is equal to u plus at. This is first kinematics equation. Second kinematics equation is v square minus u square is equal to twice at. Okay, so v square is nothing but again final velocity, u square is the initial velocity, and 2 is a constant. Okay, and a is the acceleration, and t is a time. So this is the second kinematics equation. And third is nothing but what? When you are projecting the object, that object covers some distance. Okay, so we are defining the distance s is equal to ut plus half at square. So s is the distance covered, u is the initial velocity, t is the time. Okay, and plus half is a constant, a is acceleration, and time is t square. So basically whenever the numericals asked based on the three kinematics equation, then they are giving all these initial final values. Sometimes they are giving directly and sometimes they are giving indirectly. Suppose they are saying object is at rest condition initially. Object is at rest condition means that object is not moving, that is not in motion, that is at a rest condition. So velocity possessed by the object is equal to how much here? 0. So u is equal to what? 0. So in that case this terms u becomes what? 0. So that's what understanding of this derivation and learning these three equations are very important, because entire chapter based on these three equations and the questions mostly asked based on all these three questions. Even graphs are also very important from this chapter. So v is equal to u plus at, v square minus u square is equal to twice of at, s is equal to ut plus half at square. So these three kinematics equations are very important. Their meanings, usual meanings are also given, that also you can learn. So in the next class we can do it, we can do the derivations for each and every kinematics equation, and in the next class only we can discuss the uniform, non-uniform distances or non-uniform acceleration or the speeds, that also we can discuss. Uniform motion, non-uniform motion, what are the concepts are there, that we can discuss in detail in the next class. I hope maybe you understood what is the kinematics, rest condition, motion, then speed, velocity, average velocity, acceleration, instantaneous speed, velocity and acceleration. Okay, and these are the three kinematics equation. Differences I already gave in speed and distance and displacement, speed and velocity. So prepare these points properly, because mostly they will ask this in an exam. Okay, so prepare that, and in next class I will give the derivation of this. Okay, as well as we can discuss some other points from this chapter, and once we finish this then we can go for the numericals. Can you get in here? So copy this everything from the board. I hope everyone is getting. If you are not getting, kindly ask me. Keep the message in the chat box so that I can help you to rectify your doubts or queries. Okay. So, and kindly attend the sessions on time so that we can finish it on the time, because I can able to take 1 hour maximum. If I extend 1.5 hour, people don't have that much patience. Okay, so okay, everyone copied this much. Okay, so I will end this session. So tomorrow's timing same. If suppose any internet issues are there, I will message you, because today I had some problems in Google Meet. So because of that class has extended for an half an hour. So that's what I am not able to message you. So once it finishes, then I immediately messaged you. Okay, thank you. Ryan, you can send me the details when you are traveling, at what time. So according to that I will adjust. Okay, just let me know on the WhatsApp. Okay, I will check and I will let you know the convenience. Okay, bye everyone.